Okay, so let us continue with our revision. This is question 2. Then we start with the first question there. They're saying if events A and B are independent, okay, show that the events A complement and B complement are also what? Independent. Okay, so how can we show that A complement and B complement are also independent events? Okay, so for us to prove this claim, we first have to know like 4 definitions. Okay, so the first one is what we call as the De Morgan's law. Okay, so the De Morgan's law states that if I have something like this, okay, if I have A complement, okay, intersection B complement, then this is the same as what? A union B. You put them in brackets like this, and then you say complement. Okay. The second thing, we have to know the definition of what independent events are. Okay. So if two events A and B are independent, then it means that the probability of A intersection B, okay, is the same as when you multiply the probability of A with the probability of what? B. So this is what you need to know, the second definition. The third one, you have to know the union of probabilities, okay? So if we say the probability of A union B, this is the same as the probability of A plus the probability of B, and then we say minus the probability of A intersection what? B. Okay, and then the fourth thing that we have to know in order to prove that claim, we have to know the complement rule, okay? So the complement rule states that if you're finding the probability of the complement of any event, okay, let's say the probability of A complement, this here is the same as 1 minus the probability of the event what? A. So if you know this definition for independent events, you know the definition for the union of the probabilities, and then you also know the complement rule, okay? It will be very easy for you to prove, okay, that A complement and B complement are also what? Independent events. Okay, so these are what we are going to use. So in the question, we were told that A and B are independent, okay? So if A and B are independent, then it means the probability of A intersection B, okay, is equals to the probability of A multiplied by the probability of what? B. So this is what we know from what we've been taught in the question. And then now we want to prove that A complement and B complement are what? Independent. So we simply have to show that the probability of A complement intersection B complement, okay, is the same as the probability of A complement multiplied by the probability of what? B complement. So this is the claim that we want to show. So we can start from what we have on the left and then see if we can get what we have on the right there, okay? So I'll start it by writing probability of A complement intersection B complement is equals to, okay? So now, remember by the De Morgan's laws, we said A complement intersection B complement is the same as it's the same as A union B, and then you put the complement outside, okay? So this one here that is inside, I'm just going to write, this is the same as the probability for, and then I write what is inside here, okay? So by the De Morgan's law, I know that this guy here is the same as A union B, and then complement outside, okay? So we are finding the probability of that. Okay, right, so this is the probability of A union what? B complement by the De Morgan's laws. And then this is going to be equals to, okay, from here we're going to use the complement rules. Okay, so the complement, always remember they said if I find in the probability of the complement of an event, it's the same as 1 minus the probability of that event. Okay, so here, since we have the probability of A union B complement, it's going to be the same as 1 minus the probability of A union B. Okay, you can see that the complement has disappeared now, right? Okay, and then from the union of two events, this guy here, it was defined in this way. Okay, probability of A union B, I said it's probability of A, probability of B minus the probability of A intersection B. So I'm going to write this as that expression. So I'm going to say this is equals to 1 minus, and then where there's this probability of A union B, I'm going to write probability of A plus probability, okay, of B, and then minus the probability of A multiplied by the probability of what? B. Okay, and then I close the bracket like this. So this whole thing here, we've replaced it with what? This, okay. All right, so what do we notice? What do we notice, okay? So here I've put probability of A multiplied by probability of B because the intersection there, the probability of A intersection B, okay, is the same as this guy here, since A and B are what? Independent. Okay, so from the definition of this, you notice that at the end there we have this. Let me show you. So at the end there we have the probability of A intersection B, right? Okay, but since A and B are independent, we're given in the question, it means that this guy here is the same as writing this. Okay, so I hope you're not lost there. So that's how we got, that's why I wrote this, okay? And then after that now, notice what I'll do, okay? I want to multiply this negative throughout with everything here, okay? But I won't do that. Instead, I'll multiply this negative by this first probability here, okay? And then I'm going to put whatever I have here in the brackets and this negative outside. So this is what I'm going to do. I'm going to say this is equals to 1, okay? This negative multiplied by probability of A to be minus probability of A. Okay, and then the next thing will be to multiply this negative with this negative and that, right? Okay, but I won't do that. So see what I will do. I'm going to say negative, the one I'm supposed to multiply this with this, okay? And then I'm going to put whatever is remaining here in brackets. I'm going to say probability of B minus the probability of A multiplied by the probability of what? B. So this is what I have here. Okay, and then from here, we can see that this B here is common, okay, with this expression I have in this bracket. So I'm going to say this is equals to 1 minus probability of A, okay, then there's this minus here, and then in these other brackets, I'm going to factorize the probability of B because I can see it here and there. So what am I going to remain with when I factorize this probability of B from this expression? Here I'm going to remain with 1, then minus probability of what? A. Okay, so this is what I remain with. Okay, and then from there, what do you notice? Okay, what do you notice from that expression that we have there? Okay, we notice that when I look at this expression here, okay, when I look at this expression here and this expression here, I can see something that is common. Okay, so what is common between those two expressions? We can see that the 1 minus probability of A, I can see it here. Even on the other side, I can also see 1 minus probability of what? A. So what am I going to do? I'm going to factorize it, okay? Because it's in this expression here, it's also in this expression there. So it's common, okay? I'm going to factorize this 1 minus the probability of A. So I'm going to say 1 minus probability of A, okay? I factorize this guy from this whole expression. It means when I factorize it from here, I'm going to remain with what? 1, okay? So open brackets, I'm going to remain with 1. And then if I factorize it from this expression here, what am I going to remain with? we're going to remain with the minus of the probability of B, with this minus, okay? So it will be minus, and then I'll remain with it, the probability of what? B. Okay, so now we can see that we have 1 minus probability of A, and then 1 minus probability of B, okay? So by the complement rule, by the definition, what did we say? Okay, if I can go back here, we said if you're finding the probability of A complement, it's the same as 1 minus probability of A. So meaning if I have the probability of B complement, it will be the same as 1 minus probability of what? B. So we can see that that's what we have here. 1 minus probability of A is just the same as probability of A complement, and then multiplied by 1 minus probability of B is the same as probability of what? B complement. Okay, so here our proof is complete. So we can see that we started with the probability of A complement intersection B complement. And we've shown that this here is the same as probability of A complement multiplied by the probability of B complement. Okay, so the rule for the independent event is satisfied. Okay, so we can say hence proved. Okay, so don't forget to use those 4 assumptions that I mentioned earlier. Okay, so thank you so much. Let's go to the next question.